Next, we have an important and interesting talk on integrating DPDK with storage applications, which will be delivered by Mr. Vishnu and Mr. Mayank from Maya Data. Mr. Vishnu is a senior architect at Maya Data, and he is always eager to learn. He loves math, algorithms, and programming. He has a good experience in storage protocols, ZFS, FreeBSD internals, Linux, and device drivers. He enjoys playing table tennis, and he continuously crosses out different destinations by taking an extra mile, as he is an AV traveler as well. Mayank Patel from Maya Data is senior software engineer. So let us give them the stage. Please go ahead. Thank you so much.
Thanks, Swarna, for the warm welcome. Hi guys, hi everyone. I'm Vishnu. I work at MyData. I'm the senior architect at MyData. And with me I have my colleague Mayank. He's a senior software engineer at MyData, and who is also co-presenter of this presentation. So basically we started exploring the SPDK, DPDK sometime last year, and we want to integrate with our application, which is the storage legacy application, and so we want to give out as a presentation our learnings on behalf of my team, so that will be helpful for the beginner users or intermediate users of the DPDK and SPDK. Here is my agenda. So I'll just start with my problem statement, where I will be providing a little bit background on what I'm doing and what's the problem statement. Then with this, what our team found with the current set of legacy applications, and then what are the possible solutions, how to implement them, so what are the different approaches we have, and then I conclude with the future work with some results. Right. So, and the problem statement, I'll with a little bit of background. You can see the OpenDB as the name under that slide. So it's our open source project, which provides the persistent storage to the containers through, again, a containerized storage. So where we put our file system storage engine into these containers, and so that the containers can use this. We are using ZFS for this, which is very rich in storage features, and also like very well tested for it since a long time in the industry being there. The best part also is like it have a way to create the libraries where we can user space libraries where we can stitch them, link them to our user space applications and provide our storage engine. But we were using till last year in the kernel, and it was well and good. But when tried to use it in the user space, we have some issues with the performance and such things. So that's our the analysis which my team was doing, and this is our the thing there. The very first most thing which we found is our application is basically depends on the logs for synchronization, and being now in the user space, we have a lot of the system calls happens, and then a lot of context switches happens, and which was like unnecessarily wasting CPU cycles on this rather than the real work, right? And then like now you need to depend on the kernel for scheduling. It doesn't mean in the kernel also for threads or the kernel provides it, but the point here is usually legacy applications are heavily threaded and multi-threaded, right? Where suppose a signal has to be given a separate particular thread, but the scheduler can actually kick in, and then kernel can give it to a different thread, and which actually doesn't do any work until it gives this where the signal come. So it had to move the thread into run state. So that kind of dependencies, the issues with the scheduling we were noticing. And then there comes the frequent memory allocations which will happening in the legacy applications. Again, depends on the logs if you use our own mempools architecture. We use heavy requirement for the memory, which leads to a lot of pace faults happening regularly, kind of issues. And being now in the user space, we need to copy the data from the device to the user space through the kernel, and so it involves multiple copies. Right, so finally, we ended up in like something which we cannot keep up with the trend of the current hardware moving, and due to this, high latencies or high and such kind of issues. So I mean, most of us know what will be the possible solutions for this is like we use the lockless data structures, so that these threads can communicate by by adding or getting the things from this data structures, and so that we'll have a less number of multiplexes happening. To avoid the kernel scheduling issues, like we need to follow the reactor pattern, where we will be having our a thread which will be in a poll mode and then taking the work from other threads and such kind of thing. So huge spaces provides us the ability to avoid the phase faults. So we and now to avoid the multiple copies from the kernel, integrating with SPDK is the best part to happen. So these are kind of which means that the best fit is to use DPDK and SPDK into our applications, right? But the point is like how do you stitch these two and then use SPDK things into the legacy applications? So my colleague Mayank will explain on the journey which we got, like how we try to integrate this with our legacy application.
Thanks, Vishnu. Okay, so I will share basically a brief presentation on whatever experiments we have done to integrate DPDK with our storage legacy application, which is GFS. So first I will give basic overview regarding integrating DPDK libraries with legacy applications. So as you are aware that we can use either shared library or static library, and to compile shared library and static library we can use this config flag, and we have also used this extension application makefile from DPDK MK to statically link DPDK libraries with our application, and also aggregated object file with our application. Okay, and one more thing, if we want to integrate DPDK library with our application library, then we have faced some issue. So I thought of highlighting this. Okay, so DPDK library use constructor in libraries to initialize a basic layer for EL abstraction layer. So to call this library, to call constructor, we need to make sure that all the libraries are linked with your application shared library. So that to make this linking forceful, we can use this no as needed flag. So this will make forceful linking with the libraries, and we can use RTEL init, this function, to initialize RTEL abstraction layer. Okay, and next we followed this memory allocation from RTEL library in our legacy applications. So from this RTMalloc we can use memory from huge pages. So this is contiguous memory, so we can remove overhead of TLB misrate and also address transformation at kernel level. But what we face that this RTMalloc API uses spin lock to synchronize memory allocation from memory zone. So in legacy application there are many threads. So spin lock causes overhead, huge overhead, and which internally degrade performance. So to resolve this, we move to the mempool, which is cache-based allocation with mempool library. So what we have done is we have created one memory zone with fixed size object, and with this mempool library we are allocating or freeing the fixed size object by using RT mempool get and mempool put operations. So which is internally using cache operation to manage this mempool. Okay, now how to remove for locking, we have used this ring library. So as you know that in legacy application there are number of threads. In GFS you can say we have around more than 500 threads. So to synchronize this we have used mutex, and which is causing huge overhead in performance. So what we have done, we redesign, and so the main core operation we have changed it to one thread, and other slave threads are processing queue events to the core thread by using ring library. And this queuing and dequeuing consume only single cache operation, compare and save operation. So to integrate DPDK, we need to redesign. So is there any other approach which includes minimum redesigning? So my colleague Mr. Vishnu will explain that approach.
So basically now to use our SPDK with these legacy applications, we ended up in redesigning our application to have this reactor pattern to be involved, right? But and also like still there are many other the places where we want to do that But we thought of like, is there a way to minimize our redesign so that we can integrate it with our the legacy applications and use still the SPDK and features. So which is where the team member we try to get to the client server model where it runs over the SPDK, vhost user thing. So we call it as like vhost user, the client on the right, on the left side if you see. So the right side which we have is the SPDK vhost user server running, and it will be it listens on the Unix domain sockets. And so what we done is like we have the vhost user client library which is written and can be linked with the legacy applications. So as part of initializations, they talk on the whatever protocol handshaking, and as part of again the initialization process, what vhost user client does is it creates the shared memory on these huge spaces and share these FDs over the these Unix domain sockets with the vhost server. And now once this vhost user server gets these FDs and maps this memory, so now both the process can actually see the data and then they build and they communicate again to get the ring buffers created around it. So that way they start the vhost user, when the legacy application want to send an IO, this vhost user client puts into the ring buffer, and which will be picked by the server and served back into the ring buffers again. So this way we will be avoiding dedicating our codes to the threads where vhost user actually can be some kind of, it can be done based on the workloads as a pull mode also, or it can be with an event FD kickback the vhost user client, like the work is completed in such kind of ways we can do that. So it's a very minimal library which has been done for prototyping, and it's a open source, and it's available at that openEBS/vhost-user. The idea is to, as I mentioned, we want to integrate this with the legacy applications and replace these read write calls with the going through the vhost user client. So currently it's provided with the read and write IOPS and the ops, and then the sync and async variations of the write operations. So as I mentioned, like instead of using the traditional device, we'll be talking to the vhost server on the Unix domain socket. So the results are like basically we baseline with our SPDK using the NVMe user space driver, and which was giving us 500,000 IOPS. With this vhost user mode client and server model, we got 90% of it reached. And when we tried with SPDK and libIO, which does a simulation, we got 80%. So basically, if you see, we just got the 10% of the benefit from the host client and server. But this is a very minimal, the very starting, the prototype we done, and there's a lot of future work need to be done at. So which involves like we want to send multiple V-rings so that we can send multiple IOs to the parallel. Also we want to verify with multiple devices and CPUs, so where the SPDK really works well, right? So and also still the concern is still there where our legacy applications can really utilize this SPDK things without much of the redesign. We're still working on that. That's it. Questions?
We are open for questions.
Hi, I'm just trying to understand the reason why you have used the vhost user and vhost client. Are you communicating between two virtual machine or containers,
You're
or
right.
just because it's providing you a localized ring interface?
No, okay. Right, as OpenEBS is the open source, the project which provides the storage for the containers. So which means that our storage engine will be running, and we talk to multiple applications which are running in the containers again, right? So that is where we want to, when we want to run our storage application in the containers, we have so many containers running in the node, and how do all of them can make use of the SPDK thing. That's where we ended up, we want to go with client server model, where we have a single container which is running SPDK, our vhost user server will be able to talk to the disk, and all other vhost clients which actually provide the storage to the other containers talks to the vhost user server. So here the legacy app is is my storage engine, which is actually providing storage interfaces to the end application that can be DBs, which are running in the different containers.
So this is a very naive question, I think. When you say legacy app, what kind of applications are you talking about?
Okay,
I mean, what you would not like to change, because you're trying to change here by plugging in a vhost client underneath the legacy app, even though you said you would not like to change the legacy apps, right? So what applications are you talking about?
So our legacy app is the storage engine, which is based on the ZFS. So okay. So we have this Kubernetes environment where the containers are running in the multiple nodes, right? So each container is having its workload. It can be DB or it can be some application running there, and they want a persistent storage. So the idea is to provide the storage as well through the containers. The storage actually provided by putting the storage engine in the container itself. So these containers talk to each other. Now this to perform well, right? For this DB to perform well, my storage has to be fast enough and make utilize of my disk. And now I have for every workload, my idea is to have micro storage engines in my legacy app. For your question, the answer is my legacy app is a storage engine. So for every workload, we have micro storage engines running in each container. So if I have 100 containers workloads, I have basically 100 micro storage engines which will be running, but can be using the same disk, and they communicate through this vhost server, vhost to the server.
Okay, so one last question. So does this diagram show that you have modified your existing apps?
No. So this one doesn't show. We have not modified the legacy app in this case. What we done is we just replaced our read-write calls. Okay, modified a little bit, very minimal, not like complete redesign. vhost user client provides these APIs to do reads and writes. So instead of doing the reads and writes to the disk or the traditional storage, that goes to this vhost server, vhost user, which is embedded with the legacy app.
Just to add on to the previous question, this vhost user client that you're mentioning, is that the option in the QEMU where we select virtual interface for storage?
Exactly. It's not that exactly. We wrote it, and it uses the same thing. I think vhost user server also is for this QEMU communication only.
Yeah,
so
but
that's for the virtual missions.
From the virtual side, if you want to write to a disk, you can set that option instead of the complete disk emulation part. So I was just wondering whether that is the same kind of interface that you're using here. So in that case, your legacy app or anything that is running in your container or VM need not be modified. So just query on that. Thank you.
Yeah, thanks.
Any more questions? I hope we are good to go.
Thanks a lot.
Thank you so much, Mr. Vishnu, and thank you so much, Mr. Mayank. It was a pleasure having you.